Okay, so good morning, everyone. In this presentation, I will introduce you to automated software tools to apply and deploy modern AI in arbitrary environmental and climate applications. I will present AIDE, which is a versatile ML toolbox for extreme events analysis, and CAUSEME, which is a web platform for learning causal relations from time series data. I will exemplify this in a bunch of examples. And the idea is basically to automate AI pipelines for problems involving Earth data, from remote sensing images, reanalysis, or climate data. And probably you know that in recent years, we have witnessed a wide range of successful stories of machine learning in the Earth and climate sciences. And we have now, for example, algorithms that can detect floods and droughts, anticipate impacts, predict and so do precipitation forecasting from radar. Or recently, there's like a big hype on algorithms for weather forecasting. The question here is how to disseminate all these kind of complicated models and algorithms and make them really truly accessible to a wider community. And how can we use these tools, develop them, and apply them when, I don't know, for example, a company or an organization has limited resources or expertise? The answer is basically automating AI, right? So the first work or the first sort of automated tool is called AIDE. Let's go for it. This basically is a toolbox that implements a fully operational pipeline that can load arbitrary data, develop AI models, and evaluate them and visualize the results. In total, there are more than 100 models for detection, segmentation of images, also characterizing events, metrics for evaluating performance of the algorithms like accuracy or robustness, and also to visualize the results. Everything is written, let's say, in Python, and it's free and open. Here, for example, imagine that you want to detect outstanding temperature anomalies. You want to deploy an algorithm that considers both space and time characteristics. In this example, the algorithm runs through 2010 and detects some anomalous blobs around this region in Russia in July 2010. And from here, the algorithm, of course, can detect this anomaly, can compute parameters, area, intensity of the event, and other indicators. And of course, you can then relate them to other impacts, right, of these extremes. The AIDE toolbox can also generate a full table of model comparisons with different metrics on accuracy, robustness, also considering space, time, or altogether spectral information if you are working with optical images. AIDE can generate detection maps, can detect these extremes, and can, of course, plot some spatial profiles. But more than that, we are really interested in learning or understanding why is this happening. And AIDE can also generate explanations for these anomalies through space and time. This is what we call the explainable AI module in AIDE. Here, AIDE, for example, tell us that this combination of dry fall followed by a hot springtime may give rise to this severe drought in Russia. Let's go now for the second development. The second tool is called CAUSEME, and basically it's a platform. It's a web platform that can learn causal relationships from data, in particular from time series data, and can be very useful for explaining and understanding problems. And CAUSEME is more focused on understanding, as I said, not detecting events or characterizing events, but more understanding what are the root mechanisms. And understanding disasters and their impacts is very challenging because many variables are involved and intertwined, right? And understanding means answering why and what if questions, not what questions, as we saw before in AIDE. CAUSEME automates this process of discovering causal relationships from time series data. So from time series, you want to learn a causal graph, and then this causal graph basically explains your problem, and then you can start quantifying impacts there. As with in the standard machine learning pipelines or algorithm or literature, here it happens the same. There are many methods of causal discovery and causal effect estimation, and this requires a lot of expertise. So CAUSEME basically automates this. Let me give you just an example. CAUSEME allows us to describe these causal mechanisms, explaining internal displacement in the Horn of Africa, for example. No? And this also, there are like many variables involved, like conflicts, water or food prices, or agricultural practices, or extreme events. For example, this area has been, suffered like acute heat waves and floods in the last decade. We worked here at the district level and collected a lot of socioeconomic and environmental data, and then CAUSEME learns causal graphs for different districts that can actually identify what are the main roots or the main causes of what is happening there. Let me just run this simple demo. Basically, the CAUSEME platform can upload data, time series data. Of course, you can visualize them. You can select a particular causal discovery method. If you're an expert in that particular technique, maybe you can tune it. Otherwise, you can basically schedule a job. You can schedule jobs for many different methods, and you can compare these different methods. How do they perform? After some times training in our server, basically it deploys causal metrics and graphs. So basically it is reflecting what are the causal relationships within the data. Of course, you can trim down the threshold so you can get rid of less important edges. And there are several ways where you can visualize the relationships between data. After that, you can save all the results and generate your, for example, your causal forecasting models as well. Okay, so from there is also this possibility, this capability of the CAUSEME platform, where you can, after you have learned a causal graph, you can automate the description, because there is a ChatGPT module that basically explains the causal graph for you. In this particular case was a study involving climate-induced migrations. So that was it. As a reminder, I would like just to say that our main purpose while developing these tools is automating AI, and AIDE is for extreme event analysis, and CAUSEME is for discovering and explaining relationships in data. So thanks for your attention, and I'm happy to take questions and discussion around these tools and opportunities and of course limitations that they have.